Okay, in this lesson we're going to talk about solving systems of inequalities. So we did systems of equations before, but now we don't have equal signs, we have inequality signs. So we're going to do systems of inequalities. And we're going to solve them by graphing. So let's do this one first. X minus 2y is less than 6. I'm going to graph this line, and then we're going to shade one side of it, and that will give us the inequality. So x minus 2y equals 6. It's in standard form, so we're going to find the x and y intercepts. Let's find the x-intercept first. If the x-intercept, where it crosses this axis, is when y is 0. When y is 0, it'll cross this axis. So let's go ahead and plug in 0 for y. And that gives us x equals 6. So when y is 0, 1, 2, 3, 4, 5, 6. We're at 6. I didn't actually need to plug it in, because if I get 0, it just takes that part away. Let's find the y-intercept now. And that's when x is 0, so this part goes away. So if you divide both sides by -2, you get y equals -3. So at 1, 2, 3, 4, 5, 6, I accidentally erased that point. And when x is 0, y is 1 to -3. So it's going to go through these 2 points. I'm going to use my line tool. I'm going to use a dotted line. See if you can remember why I might use a dotted line. Okay, so in this case I'm using a dotted line because we have this inequality sign. It's just less than. It's not less than or equal to, it's just less than. Okay, so I'm also going to shade now. I want to shade the things that are less than this line. X minus 2y, when x minus 2y is less than 6. So let's actually go ahead and solve this for y. So I can show you. So I subtract x from both sides, and this is what I get. Divide both sides by -2. I gotta flip the sign because I divided by -2. And this is what I get. My y-intercept is -3. My slope is up 1 over 2. And I have the y that's greater than that. So I'm going to shade the y's that are greater than this. This is the top. It's kind of different than what you might have expected because this is less than, but it's because that -2 flipped the sign. So you might want to just go ahead and solve it for y every time, or if that might help you. Okay, so all the stuff above that line, it's all of this stuff, all the way up to infinitely close, but not actually ever touching that line. I guess I can't erase that. Interesting. Okay, can I erase this stuff? Wow, my computer is not happy with me right now. It's going very, very slow. Alright, so let's go ahead and graph this one now. Y is less than or equal to, it's already solved for y, so we know we're going to shade underneath this line. It's in slope-intercept form, so we got the y-intercept 1, 2, 3, 4, 5 is this value, plus 5. Then we're going to go down 3, because it's rise over run. So down 3, 1, 2, 3, into the right 2. Or I could go up 3 into the left 2. That's fine also. So I need a line that goes through those points. So let's go ahead and get that. Uh-oh, I need a red line. Let's undo that. Let's get a red line. And this time it needs to be a solid line because we have this equals to sign. My computer is not happy with me at the current moment. It's going very slow. I might have to redo this video. Okay. I'm just gonna stop because it's not happy. Okay, and then we want to shade underneath this line. So all of this stuff is a solution to the bottom line. Not these little dots. I don't know what those are there for, but a solution to this top blue equation is the stuff that's shaded in blue. Any of those points will give you a true statement here. any of the points in red will give you a true statement to the bottom equation, and anything that's both blue and red, so all of this stuff over here, the stuff above this line and below this line, will give you a solution that's true to both equations. And so the solutions to the system of linear equations is all of this stuff. So I didn't need to shade this red and this blue. This is just the solution. Alright, let's move on. I'm actually going to pause this video and see if I can figure out. Well, I couldn't figure out why it was going slow, but I want you to go ahead and try and solve this equation. Okay, so here I've graphed the solutions. The blue line is the graph of the blue and the red is the graph of the red. Make sure you have a solid line here and a dotted line there. And then the solutions are the things that are greater than this x line, x equals -3 line, and less than the y, this top line here. And so it's the stuff that's shaded in purple. Okay, so now we're going to have a system of inequalities with a word problem. So we got to write the system of inequalities and then solve it. An entrance exam has two parts, a verbal part and a mathematics part. Sound familiar? You can score a maximum total of 1,600 points. Should start to be sounding like this. For admissions, the school of your choice requires a math score of at least 600. Write a system of inequalities to model the scores that meet the school's requirements and then solve the system. Okay, so a system of inequalities. Your math score plus your verbal score has a maximum of 1,600. So that's going to be less than or equal to 1,600. Probably less than for most people, but it's possible that you could get a 1,600. You have to get a math score of at least 600. So you could get a 600, so you can put an equal sign, that would be okay, but it has to be at least 600. But then also, remember, your maximum math score is going to be 800. Your maximum verbal score is going to be 800. We're not going to draw these on here, but I'm going to amend the graph at the end to include that. Okay, so we want to do, let's just call this math and this verbal instead of x and y. So your math plus your verbal score is 1,600, so at 1, 2, 3, 4, 5, 6, 7, 8. So let's say you had a 0 on the verbal and you got a 1,600 on the math, which isn't actually possible, but we'll just go ahead and graph that for now. Or a 0 on the math and you got 1, 2, 3, 4, 5, 6, 7, 8. So we'll call this 200 and that's 200. This would be the graph. So I'm just going to go ahead and draw it. Solid line. Okay, 1,600 to 1,600. And you would have to get below that. So you're somewhere in here. Okay, these are all the possible scores. But you also have to get a math score greater than or equal to 600. So that's 2, 4, 6. This is 600 on the math. So this is that line, m equals 600. But you got to get greater than that. So that means these are only the possible solutions that you could get. But if you remember that you actually can't get above an 800 on the math, 2, 4, 6, 8, none of these scores are actually possible. Go away. Erase. Alright, so that line that I just drew, that's 800 for the math. You can't get higher than that. And you can't get higher than 800 for the verbal, which is 2, 4, 6, 8. So this stuff right here, that I'm going to just erase everything else except for that. That represents all the scores that you could actually get. Okay, you have to get at least a 600 on the math, which means you could get a 600 on the test all the way up until a 1,400, which is what this point would represent. That would be an 800 on the math and a 2, 4, 6, oh, and a 1,600, I'm sorry, a 1,600. So the highest you could get would be an 800 on both. That would be this point. The lowest you could get would be a 0 on the verbal and a 600 on the math. Anyway, the correct solution is what I had drawn before. this actually, this shaded part is probably the best solution, but I would also accept the triangle with the shaded part blue. This would be also, I would accept this as a correct solution. Okay, so now we're going to do, what if you don't have two lines? Well, it's the same thing. You graph each of them, and the shaded part that overlaps is the solution. So I want you to pause the video and see if you can do that yourself. And now I'm going to solve it, and you can check and see. Y is less than 4. It's just less than, so we're going to use a dotted line. We're going to go up to 1, 2, 3, 4 on Y, and I'm going to put a horizontal line on my graph. This is the line y equals 4, so less than 4 is anything that's below this line. Okay, now in red, I'm going to graph the other thing. So you remember the vertex for an absolute value function is found here at negative b over m comma c. That's your vertex. So I'm going to go ahead and find that vertex. B is negative 3. So it's negative 3 over m, which is 1, comma c, which is 0. So negative 3, 0 is my vertex. 1, 2, 3. That's this point. Now I could pick points on either side to figure out what the graph would look like, but this is what it's going to look like. It's going to go up here. This is going to be a solid line because we have the greater than or equal to, and we're going to shade above it because it's the y values that are above that line that work. So we're going to shade above this. So we want to shade the things that are above the red line and below the blue line. So that's all of this stuff in here. That is the solutions to both of these equations. And you can pick a point out of there and check and see if that's true. So let's pick this point. Okay, this is the point negative 3 comma 1. 1, 2, 3 comma 1. So that should work for both of them. Is that below the line y equals 4? Yes, I have 1 that's below y equals 4. Is it above this? Well, let's plug it in and see. Plug in 1 for y and negative 3 for x. Negative 3 minus 1. Is 1 greater than or equal to this? 1 is greater than or equal to negative 3 minus 1 is going to be negative 4. The absolute value of that is 4. Is 1 greater than or equal to 4? No, it's not. So that means this is not a solution, so that means we have shaded the wrong solution. Here's the reason why. It is negative b over m, but b is negative 3. b is negative 3, and I just wrote 3. So the vertex is actually at 3 comma 0. So let me put this in red. 1, 2, 3 comma 0. And the graph should be over here like this. Okay, so I did that on purpose to show you that checking your solutions is really important. Okay, that's an easy mistake to make. I missed a sign, right? But if I check my solution, I just picked a solution and it doesn't work, then that means I've done something wrong. So I need to go back and check my work. Checking your work is really, really important in math. Okay, so let's check our work again and see if this works. Let's pick this point this time. Okay, this should be a solution to both of these equations. This is 1, 2, 3, comma 1, 2. So 3 comma 2 should be a solution to both of those equations. Let's plug it in and see if that's true. It's obviously a solution to the first equation because 2, the y value, is below this line, y is less than 4. So is 2 less than 4? Check, it works if I plug in 2. Let's plug them both into the second one. 2 is greater than or equal to 3 minus 3, the absolute value of that. That gives me 2 is greater than or equal to 0, which is also true. So this solution works. So you could try a bunch of solutions and that would make you even more sure that it works. But I'm pretty confident that I got it right this time. All of this shaded area is the solution to this problem. So I want you to go ahead and pause the video and try and solve this one. Okay, so this is the solution that you should have had. The red is the graph of that absolute value function. The blue is the graph of the line. We should shade below. Oh, no, we should be shading above the blue line and below the red line. So above the blue and below the red is over here. So I've made a mistake again. So I'm just going to leave the purple alone. I'm going to shade it in blue. Blue is the solution, not purple. Okay, so below the red and above the blue. And let's check that. Let's pick a point over here and see if that actually does in fact work. This is the point 1, 2, 3, 4, 5, 6, 7. So we're at the point 7. 1, 2, 3, 4, 5. 7, 5. Should be a solution to both of them. So make sure you actually check your work. So is 5 greater than or equal to negative 2 times 7 plus 4? I'm plugging that into this top equation. Is 5 greater than or equal to negative 14 plus 4? Is 5 greater than or equal to negative 10? Yes, it is. So it works for the top equation. Let's try it for this next one. The y is less than or equal to. So is 5 less than or equal to the absolute value of 7 minus 4? 5 less than or equal to the absolute value of 3. Is 5 less than or equal to 3? No, it isn't. So again, we've made another mistake. 7, 5 is not a solution to both of ours. So let's think about this. This is saying the y values that are less than or equal to x minus 4. Do I have that shaded correctly? Below the red. Yes, all of this stuff. The blue and the purple combined is what's below the red. And then the y's that are greater than or equal to negative 2x plus 4. So I've shaded correctly. There must be something wrong with one of my lines. And in fact, there is. The slope of this line is incorrect. The slope is negative 2, which means it should be going this way. I have a positive slope on here. So I need to get rid of this line and put it on here correctly. So the correct line goes through 4. 1, 2, 3, 4. And it's got a slope of negative 2. So if I go down 2 and to the right 1, or up 2 and to the right 1. Okay, so that's the solution. It's the y's that are above this line and below this line. So it's all of this stuff down here. So let me continue this line. It's all of this stuff that should be the solution. Let's check it. 1, 2, 3, 4, 5. Let's just use this point. 5, 0. Let's plug it into the first one. Is 0 greater than or equal to negative 2 times 5 plus 4? 0 greater than or equal to negative 10 plus 4? Yes, it works for the first one, but we're not done. We need to check it in this one also. Is 0 less than or equal to 5 minus 4? That will give me 0 less than or equal to 1. Check, it works for both of them. So I feel better about this solution. Okay, this is probably correct. I would need to check a few more points or check my work again to make sure, but when you check points, it really helps you. So that's 2 times in a row I've made a mistake because I did my work too quickly. Check a point really quick and make sure that you did it right. Okay, so again, another system of equations by a word problem. I'm going to skip that one, leave it as an exercise, and we can talk about it in class.